class, welcome. This is James Graves and I will be your instructor through this module, and today we're going to talk about IPv4 class ranges and public versus private in those ranges. We will also look at how we can recall where these ranges begin and end and what's happening inside of a router or a device when we assign it. And the next nugget from here, we'll get into default masks and the CEDAR notations of those masks. So let's get started. I think this is going to be a fun little deal. Here we go. Basically, what we have with IPv4 class ranges is addresses that begin class A, B, and C. They're broken up because it divides how large. Let's see, we got the wrong thing on. Let's turn that off. If we have an address here, okay, 4 different octets as we know, 1, 2, 3, 4 octets that could run across here. Our classes will be the division that takes place where we say what portion of this address is available to assign hosts on this network and what portion of this address is available to define the network. And what do we mean by that? Well, the network would be the idea of we're going to send a letter to John Doe. If we're going to send this through the post office or however we're going to get it there, we understand that we got to have some kind of street. We got to have some type of city, some type of state. This is assuming that we're sending something here in the US, and a zip code. All of this identifies where something is located or the network portion of an address. Here we'll have an individual that might reside at an address. That is the host portion of an address. Now, classes have been established where we will assign default subnet masks to these classes, which will create this division for us. Okay, from a default standpoint. That's the next step we're going to go to, is understanding exactly what that division is and how large networks as opposed to hosts are in each of these classes. From there, we're going to end up determining how we can create custom size networks and hosts based on what we're starting with, dividing them up into smaller chunks. Before we get to those next two steps, we have to understand when we see an address, we have to quickly be able to identify its portion of, its class and its class assignment. As an example, Class A. Class A is 1 through 126. What are we talking about there with 1 through 126? Well, we're talking about the very first octet of an address. This right here, that's all we have to reference. Very simple. Class A. If we have something that is 172.31.96.58, determining that that is a Class B is as simple as looking at that first octet. If we have an address that is 220.14.96.170, only pay attention to this first octet. This would be a Class C. It falls in this range. Why and how do we determine these values quickly and remember them off the top of our head? Well, it's actually not that difficult. If you go back to our data conversion piece, every bit inside of a byte has a value associated to it. And this first octet right here, the 8 bits that are in there, if they begin with this very first bit being off, regardless of what happens here down, we are talking about a Class A. So a bit pattern that begins something like that we could look at that and quickly go, oh wow, we're talking about a class A, and I know that because that first bit is off. Why is that? Well, what happens if that first bit is on? If that first bit is enabled, look what the address has to begin with, at least 128. If we go on off, regardless of what follows afterward, we're dealing with a class B, just based on the binary values. How do we get to a class C? A class C is the concept of on, regardless of what happens here down. If it starts with the first two bit patterns on, regardless of what happens the rest of the way down, we're dealing with a class C because we know this value has to be at least 192. On, off. That guy right there, we can be no higher than 223. If everything else is enabled, we have a max value of 223. If everything else was off, we know that we have a value of 192. So if you ever need to determine a class, you'll do it very quickly just by looking at that first octet and seeing what the values are. Here's the little sheet that you could have available if you want to write this down. Class A, 1 through 127. Now here's a quick little note that we need to keep in mind, okay? If we look at our chart, we don't see a 127. 127 is reserved, and it's available to every network interface card, and it allows a device to test the communication of the network address of the network card, the network interface card, to see if it's functioning properly, if it can handle TCP/IP communications and requests. Let's see that in action. So right now, if I were to take this guy and I were to ping 127.0.0.1, I'm getting a response that's coming back. Well, this is my device pinging itself to say, hey, if I send this ping packet to you, this TCP/IP communications, this ICMP echo request, can you take this request, process it properly, and respond properly? That way, if we're having problems with the device communicating on the network, we can kind of isolate devices that might be having difficulties creating communications from a protocol standpoint, meaning they can't understand this protocol, these set of rules to communicate. I'm not understanding them right now. I'm broken. So 127 we don't necessarily reference when we look at our IPv classes. Class B, 128 to 191, leading bit pattern of 1, 0. Okay, the smallest possible value it could have, if there's a 1, 0, the smallest possible value is 128. And if this next bit is not enabled, the highest possible value it could have is 191, because it takes the first 2 bits to be enabled to get to 192. So we take this one step further, on, off, meaning that on ensures that I'm at least at 192. On, off ensures that I'm never going to get any higher than 223. Therefore, when you assign a device an address, that beginning bit pattern is going to determine the class that can be associated to it, or the class that it falls under. Now we'll see these as well. We have private ranges that exist. So inside of a class A, we're saying that's anywhere from 1 to 126. Let's make that a little cleaner. 1 to 126. And we're also going to say now private range is anything that falls in the 10 network. If it is 10 dot anything afterward, 10.0.0.0 through 10.255.255.255, these octet values. If it falls anywhere in there, you are a Class A private. Now, what does that mean, private? Well, let's say that we have internet access that is flowing to our house. This is our DMARC, meaning that at this point, the ISP, they handle any problems this way. We handle any problems internal. And inside, we could assign addresses to devices that are anywhere inside this range. That's a private range. Or, what's another private range? 172.16.0.0 through 172.31. 255, or what we're probably more used to seeing here, if we do an IP config on our home, really it's anything that's XX, anything that begins 192.168. Inside of our residency, inside our home, we're going to have this addressing scheme that's going to take place. Outside, any communications that go outside of the network, we're going to have a public address. Why? This out here, this internet, is a network. No two devices can have the same IP address in a network. Considering this being a network, every device out here must have a unique IP address to be attached to this network. Every device inside here must have a unique address assigned to it to be a part of this network. Okay, so you have an internal network that we're looking at and have to take into consideration, and you have a public-based network that you are attached to if you are communicating out on the internet. That's where these private ranges come into play. Private addressing can be adjusted and maintained inside. Data is then bundled up. So we're going to send all this data here. It's going to head outside the network. When it gets to our router, so that we can route it from this network to this network, we will have some kind of translation that will take place where this internal addressing gets converted to this public addressing and gets sent out. Our public connection is going to fall somewhere in this range, one of these three, either a Class A, a B, or a C communication. And our private addressing inside is going to fall somewhere in one of these three ranges. So if I were to take my PC and I'm going to run an IP config on it, I'm going to see, you'll see I got a bunch of adapters on here from VMware. But when we look up here, 192.168.1.7. That would be my my private address. I am in a private range. That is inside my residency. 192.168.1.1. Well, when my data is being ready to be sent out onto another network, off of my network, that is my gateway. That is my router interface. I'm going to take this data, I'm going to bundle it up, I'm going to send it here to my router. My router is then going to make some kind of conversion, and it's going to translate it into this public address so that my data can then be sent. Okay, so how do I know what my public address is? You can go somewhere like ipchicken.com, display your IP, and you will get back a response. It looks like, alright, let's see here. Maybe we're having some difficulties on this site here. Hang on one second. Let's see a current IP. There we go. That would be my current IP address. In other words, when data is being sent internal to external, I have an internal address of 192.168.1.7. it is my data that's being sent off my network is bundled up. It's sent to this default gateway of 192.168.1.1. A conversion takes place and my data leaves, and it is 96.241.177.182, which happens to be a Class A address. Now, inside my network, I'm dealing with a Class C private. Private addresses cannot be communicated on the internet. If something from a private address tries to get tossed onto the internet of public addresses, it will be dropped. They cannot be communicated out there on the internet. You have to have something in a public range in one of these classes here. 96, 241, 177, 182. So we're dealing with a Class A. So I'm dealing with a Class A. That is what Verizon has assigned to my device or to my network here. So to sum everything up, we have classes of addresses, A's, B's, C's mainly, that we're going to be concerned with. They have ranges 1 through 126. Remember, first bit off. Class B, 128 to 191, meaning first bit off, on, second bit off, on, off. Class C, 192 to 223, on, off. We have private ranges, which are blocks inside of these classes that can be assigned to internal networks, so that you can create networking schemes that take place inside your corporation, your home, whatever it may be. You have public addresses, which are used to communicate on the internet. Remember 127, we're not going to see that. We're not going to use that for these kind of addressing schemes here, because that is reserved as your local loopback address, which is used for internal testing to make sure your device can receive and send data within particular protocols. That's going to sum it up for IPv class ranges, public versus private. We now have a good understanding of data conversion, our ranges, public versus private, and how these bit patterns create these divisions for us. And next we will get into IP addresses, subnet masks, and CEDAR notations. See you then.